good morning on this snowy, cold February Southern Ontario morning. It's Don the Old Radio Guy here, and today we're going to look at restoring a Viking mantle radio model RM544R. It is a tube radio, 8 or 9 tubes in it, I believe. And, well, let's just waste no more time and get started. Thanks. It's relatively standard tube complement for an AM/FM radio. This is a series string with a twist radio, which means it is a hot chassis. One side of the line is directly connected to this internal chassis, and that makes it a shock hazard. And I must say that if you are working on this, I'll quote Paul Carlson pretty well, these things can be dangerous and lethal to work on, and I definitely would not recommend anybody working on this unless you have experience with tube radios that produce relatively high voltage and have a transformerless chassis. I myself use an isolation transformer that's built into my Variac and dim bulb tester all in one. And if you are going to repair or upgrade or restore a radio such as this, like I said, I suggest you make yourself fully aware of all the safety precautions necessary. And if you are following along, thank you, Paul, you are doing so at your own risk. Now, if I can get this without glaring into the frame, that shows you the tube complement, and I'm not sure that you can read that off. Slide that over a bit. Still isn't going to be legible. It has a 35W4 rectifier, single wave rectifier, has a 50C5 audio output tube, has a 12A V6, which is the first audio amplifier and AM detector. It has a 12A L5 FM ratio detector diode and two 6A U6 IF tubes and one 6BA6 IF tube. Has a 12BE6 AM converter, and a 6AQ8, which is the FM, RF, and converter. Now, the little twist that this radio has, for some reason, they have taken the 6AQ8 and the IF tubes, all of them I believe, 6, 6, and 6, right, and they are feeding them from a filament transformer, which is mounted underneath, a nice sizable one, and it parallel feeds those. So the rest of the tubes are in series, which should, if we can do the math sometime, adds up to approximately 115 to 120 volts. So what I'll be doing today is to restoring this, repairing it and restoring it. I've already powered it up and it does work. I'm not particularly impressed with the sensitivity of it, considering that we live in a rural area here and we get one AM station reliably and very few FM stations reliably. We are just around the corner from the CBC tower, which gives us 2 FM stations, one all talk and the other one music and talk, and you could probably, they're so close you could probably pick them up with a tooth filling, but at any rate, any radio at all will pick up the CBC tower. The other stations are problematic. The favorite station that we have is in Collingwood, which presents reception problems for this area. Some radios do it well, some do not. This one does not do it well. There's a view of the top, where they're placed. The tuning gang, which is the big, this one, and this one is the RF or the converter, and the oscillator for the AM, and the two next are the RF and the oscillator for the FM. FM tube, AM converter, IF, IF and limiter, ratio detector, 12AL5 or 6AL5, I can't remember, and the 12AV6, which is the AM detector. The audio output transformer, the cans for the electrolytic filters, the FM connection, antenna, and the AM loop stick with external connection there. And it has a neon bulb for a dial light, which is very rather pathetic. I will, for the course of this video, I will make it run as well as can be. Caps will be replaced. As you can see, there's not a lot in there. The electrolytic cans will have to be replaced. The ratio detector capacitor, electrolytic capacitor, will be replaced. There are a couple of ceramic capacitors. No, there's more than a couple. 1, 2, 3, 4, 5, 6. They probably will be okay. Oh, 6, 7. I counted some more. For bypass situations, they are acceptable. They tend to be microphonic, so if they are in the audio chain, I will probably replace them. The resistors will be checked. Oh, there is a waxy capacitor. That will definitely have to go, and another one. There's our, what they call the death capacitor, which will have to be replaced with safety capacitors. I do not have safety capacitors in stock. That is a good question. 0.04. I'll have to check the schematic. I think it's 0.04 microfarad. And that will have to be replaced, and generally if you replace that with the standard safety capacitors that are, this is for AC/DC across the line and from line to chassis amounts to the same thing. So use the appropriate safety capacitor. I don't have values that large. I will have to order some. Sometimes it definitely affects the front end of the receiver because the tuning gang is quite often grounded to the chassis, and then it's returned to the B- through the safety capacitor, so it needs to be a bigger size than the ones I have in stock. Otherwise the FM and especially the AM does not work too well. It is my tendency to not restore radios just to the original manufacturer's specifications. This radio will be added to my collection, and I have been toying with the idea of changing the audio section dramatically. I was surprised at how poor the quality of the sound was, especially when you compare a similar style of radio made by Zenith, which have very bulky output transformers, feedback around the output transformer and interstage, where it makes a huge difference in the fidelity of the radio receiver. This one sounds anemic, and I was disappointed with how it sounds. I am toying with the idea of ordering a push-pull output transformer and replacing the 35W4 with another 50C5 and making this a push-pull unit. People will be screaming at me for wanting to do this, but it is something for my own use, and I get much more pleasure out of playing with the design and seeing if I can improve it. In some situations, my changes and improvements have made a massive improvement in the sound. Other times it's been a total failure, and I've either given up or put it back to the way it was or tried another design. All in all, it's just part of the way I view the hobby, and like I said, it's for my own use, so it's mine. I'll do with it as I please. I've tested the tubes. They're all reasonable, so I won't bore people with testing. I have to change the camera setup to do it. I might do one, say the output tube, which is the one that's the hardest worked, I believe, in a chassis like this. And then I'll just get started. I'll stop the recording now and reposition, and I'll change capacitors, and then I'll come back and see what improvements that's made with it. I'll also insert one tube being tested. Be back soon. Back again. Thought I'd show you the schematic that I have. I hope that's legible. Alright, it looks like I was a little mistaken in some of my designations here. I can go through this again. Rectifier is a half wave, 35W4, which produces, if I could read that, about 120 volts, there it is, 140, 34 volts. Let me swing around here. Yeah. And it feeds that first to the plate of the 50C5 audio output tube, and that's fairly standard. It does have a feedback path from the cathode through a tone control to the bottom of the volume control, and like I said, I've had this working. It doesn't really give much in the way of an improvement in sound quality, either in bass response or in reduction of distortion. At any rate, the first, or the voltage amplifier audio frequency tube, the 12AV6, it apparently is not involved in the detection, which it normally would be in a 5-tube AA5 receiver. They use something different, and I'll come to that in a minute. At any rate, that's a standard contact bias or grid bias, grounded cathode voltage amplifier. The detection for the AM is actually through the use of the grid and the cathode of the last FMIF/limiter. And you can tell that because the cathode is grounded and the secondary of the AM transformer is coupled through the FM transformer, which has a short piece of wire, would be to AM frequencies, from the cathode down through to this resistor, which provides AFC through to the AM converter, and it is now detected because of the diode action of the first grid of the 6AU6 and the cathode. It's acting like a plate in that situation, and it feeds down to the selector switch, which in the position for AM will feed that out to the volume control. So that in fact it's a very common method of using a pentode or any other tube in that detection circuit for AM when a dual diode or single diode tube for amplification is not available. Why they chose to do that there when there are two diodes included in the 12AV6. And as I mentioned previously, I might just consider changing this into a push-pull amplifier, in which case the 12AV6 would be removed and a 12AX7 would be installed, and some kind of phase inversion circuit would be used. In that case, I would normally have lost the use of the dual diode as AM detection AFC, sorry, AVC, but in this case it doesn't matter because AM detection occurs up there. All right. So maybe I'm working from the back end forward. Let's go from the forward. We have the FM front end, which is inside. I don't know whether, no, it's not focused on that, but there's a metal case there. I'll show that when I get the cameras repositioned. And there is an untuned FM RF stage, and then a converter stage, which is a combination oscillator and mixer, which is tuned. There's two gangs of tuning capacitor there. It feeds through the transformer coupled at 10.7 megahertz or megacycles into the first FMIF. That's tuned through its